So today's work is, well, it should be all review, but I'm going to teach you a way to organize things so that you will make very few mistakes. And in the harder problems, it's really going to help you a lot. And this method is also going to help us do things in the future in a way easier than the way I learned it. The way I learned things was kind of complicated, and this new method just makes things super easy. So if you look at the multiplying worksheet, the first one, multiplying polynomials, and you take a look at the first one, you see what is called a monomial multiplied by a binomial. So this is a monomial because it only has one term, and this is a binomial because it has two terms. This is the easiest form of multiplication. We're just going to distribute. So we're going to multiply the 6v into the 2v, and then the 6v into the 3. So 12v squared plus 18v. Yeah, that's it. Because we can't combine them. You can only combine terms if they have the same variables. One has a v squared and one has a v, so we can't go any further than that. Number 3 also is a monomial multiplied by a binomial, so I'm going to distribute. And I get negative 4x squared minus 6x. Does that simplify any further? No. Super easy. Well, when we get into the harder problems, we're going to use a different method. This is a binomial and a binomial. Anytime you have something 2 or bigger multiplied by something 2 or bigger, we're going to build a box that has as many boxes as the product of the two number of terms. So I'm going to build a 2 by 2 box, and I'm going to put 2n and 2 on the top, and 6n and 1 on the side. Okay. Now each little box is just the multiplication of the row and column that you find in the bigger box. So this first one is going to be 6n times 2n, which is 12n squared. The next box is 12n. Then down on the bottom row, 1 times 2n is 2n, and 1 times 2 is 2. Okay? So if you look now, we kind of have these diagonals of like terms. The top left diagonal is the n squared diagonal, and it's all by itself. So the answer would be 12n squared. The middle diagonal contains all of the n terms. We have a 12n and a 2n, which gives me 14n total. And then the bottom right diagonal is the constant one, which is just a 2. Now, I could have done this the old way, which is multiply the 2n by the 6n and write it down, 2n times the 1 and write it down, 2 times 6n and write it down, and 2 times 1 and write it down. Okay, that still works, but it's not as organized as this method. And this method already tells you which ones should go together. And when the problems get harder, you're definitely going to want to use this box. Okay, so let's do 7 together. What? That's okay. Yeah, if you prefer the other way, that's fine, but when we get to the harder problems, you'll want to use this. So x, negative 3, 6x, and negative 2. X times 6x is 6x squared. X times negative 2 is negative 2x. Negative 3 times 6x is negative 18x. Negative 3 times negative 2 is plus 6. Then if you look at the diagonals, we have 6x squared. The middle diagonal is negative 2x and negative 18x, which is minus 20x, and then plus 6. Good. Well, that's a good question. Let's switch it around and see what happens. 6x minus 2 and x minus 3. So 6x squared minus 18x minus 2x plus 6 What's the difference between those two boxes? The middle diagonal has flipped. Does that cause a different answer? No, why not? Well, is negative 2 minus 18 any different from negative 18 minus 2? No. So we get the same answer both ways. Okay? Nope, it doesn't matter. Okay, now, on these easier problems, if you don't like the box, you don't need to use it. You do need to understand how the box works because you will need it later for something different. But if we go to the back page, what? You multiply to put numbers in the box. Once they're in the boxes, you add them to get the final answer. Was that your question? Well, this one will help. On number 21, how big is the box going to be? 3 by 2 or, is it going to matter? No. So I'll do 2 rows and 3 columns. Now, you guys know how to multiply 21, right? How would you do it without the box? You would do this one times that one, and then this one times that one, and this one times that one, and this one times that one. But it's really easy to make a mistake. And then once you have it all multiplied out, what do you need to do? You need to simplify, but the trouble is, are they in order? When you line them all up, they're not going to be in order. Okay? When we multiply them in the box, everything will be nice and organized. So 2r and negative 4, 7r squared minus 6r minus 6. Is it easy to miss a term when you do it this way? Have you ever skipped over one? Yeah? Is it easy to miss a term this way? No, why not? There's a spot for every one, and the only way you're going to miss one is if you leave a box blank. So that's another reason why this is so useful. So what's the first box going to be? 14r to the third, and then minus 12r. Oh, wait a minute. Sorry, that should be a 2r. Okay, and r squared. The last one? Minus 12r. Okay, and then this one? Minus 28r squared. The next one? 24r. And the last one? 24. Okay, and the cool thing is, if we draw the diagonals, everything is already lined up for us. So my final answer will be, my r to the third is 14r to the third. My second diagonal contains all of the r squareds. Negative 28 minus 12 is negative 40r squared. And then my r diagonal, 24r and negative 24, is plus, well, one's positive and one's negative. So it's going to be plus 12r, and the last one is plus 24. So I highly recommend using the box if you have something bigger than a 2 by 2. If you like it for a 2 by 2, use it. But if you go to 2 by 3 or 3 by 3 or something bigger, the box is going to make your life a lot easier. It's pretty hard to make a mistake that way. Now, I'm not going to do 23 for you, but how big would the box be? 3 by 3. And then, if I draw the diagonals, what's the variable going to be in the first diagonal? N to the fourth, and the second diagonal, n to the third, then n squared, and then n, and then the last one will be a constant. So that middle diagonal is actually 3 different n squareds. And if you did it the old way, you're going to go like this, then you're going to go like this, then you're going to go like this, and they're going to be all stretched out, but they're going to be out of order. So you have to go back through and figure out the order in order to combine them. But the box will just do that for you. Okay? So, the answers on the first worksheet, yeah? 13? 13. Oh, okay. Look at 13. How would you do it? We're going to draw the box, and it's 4p minus 1, and the other side is also 4p minus 1. It's just 4p minus 1 times itself, not 8. That would be 16p squared minus 4p minus 4p and plus 1. It's not 0. No, what is negative 4 minus 4? Negative 8. So 16p squared minus 8p plus 1. But that brings up a good point. Is there a way for this middle column, the middle diagonal, to be 0? If one was positive and one was negative, then it would be 0. If you look at your second worksheet, that happens on a lot of those problems. Number 1 is going to be missing a middle term. So, the first worksheet, the answers are right here. Okay, if you want to come up and scroll up and down to find the answers, you have to show your work. If you don't show your work, my TAs will give you a 0. So there are the answers. And then the second worksheet, I just put the answers right on the worksheet. So you need to show the work necessary to get that answer. Yes, just do the work and then make sure that that answer is the one you get. All right, any questions? Who was not here yesterday, take the test. Was everybody here? Okay. Tests will be done tomorrow. They're mostly corrected. So I'll be working on them. If you need help, come up and see me.